Okay, in this session, we'll be mainly talking about like how can we visualize process states or process on Mac operating system. So we know that like there is a fork system call also available with Mac. Uh, so it returns 0 as a return value in child and PID of child in parent. Correct. And like when we write this code rather, like it would be returning the return values like as I stated. But what if we have to print PID of child, PID of child and its parent ID? So similarly, on the way that we saw in Linux, here, we also have a function, system calls or functions called get PID and get PPID. Okay, so let us write a code here. So we'll write disp PID.c. We'll include first the files unistd.h. Then we then we include stdio.h. Okay, int main. We'll declare one variable of the type PID underscore t, which is PID, and we'll give call to fork system call over here. Then, as usual, we'll write here if PID is equal to 0, then we'll display printf I am a child process and my PID is %d, and we'll write here get PID function call, and which would be written and printed there as a value. So we'll write again another printf my parent ID is get PPID. Let us write here else printf I am a parent process and my PID is %d. Get PID function again we'll using printf my child process ID is. Now we know that in parent the PID would be holding value for the child process. So we'll print that PID value here. We'll add here /n after every printf. We'll make appropriate changes in the code. Okay, now as we are in parent process which created a child using fork, so we'll display and my parent ID is %d again get PPID. Now in parent, like we would be printing its PID, its parent's PID and its child's PID. And then we'll write here return 0 and then code complete. So now if we save this, compile this. Okay. Here we missed a bracket at both the places. Good. So let us execute this code. So you can see that like what it is saying, I'm a parent process and my PID is 3773. My child process ID is 3774 and my parent ID is 3271. Correct. And I am a child process and my PID is 3774 and my parent ID is 3773. So we could see this, like we know now how to get the parent and child process ID. We'll make small change in the code. Okay, and we'll write a system call here for sleep, and we'll use function sleep. So we'll write here sleep for 10 time minutes. Let us compile the code and execute this. So till the time it is executing, so AUX grep a dot out. Now it already printed this value. So right now nothing would be in memory. Fine. Like for a dot out, we are not seeing anything. Let us execute the code again. So the time that we gave seems to be very small. Okay, so we'll make small change in the code. 40 WQ. We'll add one canap also there to hold it int I. You must have seen as I return the value and then give the call to the system like sleep. That's why it is not executing. So let us add 10 here now. Now you must have seen how return also works. Let us compile the code. Okay, and let us execute this. Now it is waiting. You can see like your grape is running. That's why this R plus, S plus, and S plus. So now let us see both of them terminated. Let us say like the states that we saw were S plus, S plus for both. Now what I will do is I will execute this and I will press Control Z. So I will stop it. So we know like how what exactly happens when it is controlled by the signal or sent by in the background by the signal. So you can see both the states are becoming T now. Fine. So if I write FG and if I check this, now as the time which was there for sleep mode, that the both process should enter into sleep, that already passed out. So that's why none of the process is seen here. Okay. Similarly, we'll try to see like how can we see other process states. Say for example, we'll try to see this process uninterruptible wait. So we know we have seen these states. So we'll see this one. So let us say like if I am writing PS AUX, I will take this output into a file P. Fine. So you can see P is containing output. So if we count number of characters in P like this one, so I will display that and I will redirect it to Q. So I will try to increase size of that file and I want it to be busy in writing the output. And I'm continuing this and let us see the size of both the files. Correct. Let us continue this execution. You will see like size of file is increasing. So I will reverse this now again. So we got Q. I will keep on doing this. Now you will see that like after some time, as it would be taking some time to write that data, so it will wait for a while. Like right now it is very fast doing the tasks. Correct. Now let us again change this. Now if you check, so file size is bigger. Correct. Let us make again this execution. Let us see the size again. So we got now good size. Let us do this again. So we'll increase size of Q2 in the parallel way. And so size of P and size of Q is changing. So let me add reverse it now again. I will write P, I will write Q. Now you can see it is taking a bit time now for Q. This is the size. So we'll change it now again to Q and this is to be P. Now it is taking time. Good, that's what we wanted. Okay. Now as we want to show that like when it takes time, what this cat process enters into. I mean to say state perspective. Cat, let us change this to Q. Let us change this to P. Okay, hopefully, let us check PS, AUX, and grep cat. So it must have terminated execution. Correct. Let us see the states. We'll change this thing again. So all the processes are into S. So like S plus is not there definitely for them. Okay. So we'll now change it again back to QP. Again, all of them, like if we see, let us see the state, like has it been done? So I will write this P. So like the word cat probably appearing at everywhere. So that's why it might be displaying that part. Okay. So the work is still going on. So if I write PS, AUX, grape cat. Okay. And if we go back, now we'll again change this cat P to Q. So now like we are seeing that there are multiple things added. So we'll try to control it by displaying few things. So let me clear the screen and let me display this. Now you can see that the cat command is entered into U. Okay, the work is still going on. The work has finished. So if I see now, it is removed. But if I still continue this, Okay, you can see that it is entering into U state. Now, when we say U ultimately, so let us see what exactly we mean by U. So U specifically means markup process in uninterruptible way because it is writing into the file, like it reading from P and copying the contents, combining both the files together, and result would be stored ultimately. Okay, so if we see, if I say send it to control Z in this case, you can see the state also would be changing. Now it is in T state, correct? So if I change back to FG, it would be coming back to U plus. Now both of them are in U plus because like after for some amount of time this was entered into U plus because that other was in U plus. That's why this was showing. Then suddenly when we fired again back, one could find out that it is working right now this way. Because when it was in U plus, ultimately as it is in uninterruptible case, it could not read the file, the contents of that command as a process state perspective. That's why it entered into U plus. Similarly, like when I tried again writing this, you can see the process must have completed the execution, correct? And that's how rather the process states can be visualized on Mac.